Hi everybody, welcome back. This is Unit 3, Lesson 7, and we're in this section here of the notes where it has uses of radioactive isotopes. And what we're going to be talking about is, other than the uranium and the hydrogen that we talked about for fission and fusion respectively, some other isotopes that have uses, and you have to know them. So one of the uses that we use radioactive things for is in medicine. Okay, to diagnose or treat diseases in general. The things that we use in medicine, we want to have short half-lives. And be easily eliminated from the body. Because obviously if we're putting something that's radioactive inside of you, we don't want it to stay radioactive for long. Okay, so some different medicine, or some different isotopes used in medicine. The first one is iodine-131. Iodine-131 is used to diagnose thyroid tumors. We're not going to use all these lines, so it's okay for you to write on more than one. But the idea behind this is a thyroid scan. This is your thyroid gland over here. It's located above your throat. It's shaped like the letter H is in Henry. And you can't feel it unless it's swollen or abnormal. But that makes hormones that regulate your metabolism. So if you go for a blood test, they will test you for those hormones. If those hormones come back either high or low, then they're going to send you for something called a thyroid scan. And when you go for a thyroid scan, you will be injected with radioactive iodine-131. Now again, iodine that you get in your salt, in your diet, if you ever noticed your salt says iodized, that means they have added iodine-131 to it. It will travel, iodine will travel among other places to your thyroid gland. And inside your thyroid gland, it gets used to make thyroid hormones. So there is a normal, this is your normal picture of what a thyroid gland looks like when it's taking in radioactive iodine. If you have an overactive or an underactive thyroid, that will show up. This is an overactive thyroid. It is taking in, all these dark spots are where it's taking in iodine. It's taking in too much iodine. So you're producing too much of your thyroid hormone, and you will have hyperthyroidism. You'll have a disorder called hypothyroidism. There's also underactive thyroids, and in that case, there wouldn't be very many dark spots up on the screen. Okay, or you might be able to even identify a thyroid tumor where a group of cells are taking in too much of the iodine. So we use iodine-131 anyway to diagnose thyroid tumors. We also use technetium-99 in medicine. Technetium-99 is used to diagnose brain tumors. Okay, and I think I might have an X-ray. It's the same idea. Okay, this is a CAT scan where they have injected the patient with technetium-99, and you notice there's this big bright spot here in the X-ray. The technetium has accumulated in that section of the brain, indicating that that's a group of fast-growing cells, and that's a brain tumor there that was used and diagnosed with technetium-99 for brain tumors. We use cobalt-60. Cobalt-60 is used to treat cancer. So if you have to, Lord, I hope never, but if one has to undergo treatment for cancer, they will be radiated with cobalt-60, and that kills the tumor cells, hopefully, and it also kills your healthy cells. We talked about that a little bit in class. That's kind of bad. So those are the three that you have to know that are used in medicine. We also use some things for dating. And I don't mean like, hey, what are you doing Saturday night? I mean to determine the age of things. How long something's been dead, or perhaps how old a rock or mineral is. If we are dating rocks, we use uranium-238. Geological formations. That's how we know how old the Earth is. Okay? If we are dating once living things, we use carbon-14. So things that have been alive, like a woolly mammoth or whatever. Okay? We use those. There are a couple other things just in general that you should know. Sometimes carbon-14 has another use. It's used as a tracer in organic pathways. And cobalt-60 also has another use up there. Cobalt-60 is used to radiate food. And spices. And you might go, why would you want to do that? Well, if you irradiate your food, it kills bacteria or viruses that might be living on the food, and then the food would be fresh longer and have a longer shelf life. And that might not be a big deal to you if you live around the corner from Wegmans, but if you don't have fresh food in your village or wherever the case may be, it might take a month to get it to you. And so you don't want your chicken loaded with E. coli or salmonella or anything like that. So you can actually irradiate food, which would kill harmful bacteria that might make you ill. So these are the isotopes. You have to know what their role is. They will specifically ask you questions in multiple choice. For example, what isotope is used to diagnose thyroid tumors? And you would have to know that's iodine-131. While, as we know, isotopes have their benefits with nuclear power and these among other things, radiation has its risks. And you should know that it is harmful, as we saw from Alexander Litvinenko, to be exposed to too much radiation. It can cause nausea. It can cause decreased immune function, so you can't fight off illness. It can cause burns. If you're exposed to radiation, you can get radiation burns. It can cause hair loss. It can cause sterility, which means you would be sterile and not able to have children. It can lead to cancer. And of course, ultimately is what happened with our Alexander Litvinenko. It can lead to death. So radiation can be a scary thing, but it also has many, many, many uses. Oh, one use that I forgot, and it's kind of a just for fun use. I wouldn't say you necessarily need to memorize it for the Regents exam, but there is americium. I think it's 241. That's used in smoke detectors. And we talked about that already a little bit in class, where it's an alpha emitter, and it emits this stream of alpha particles that lead to a sensor. It probably doesn't look like this, but this is my interpretation of it. So your americium emits these particles, and when smoke or fire get in the way and they block that stream, excuse me, the sensor goes off. Okay? And when the sensor goes off, obviously it makes the smoke alarm sound, but I think it would be really cool if smoke detectors made animal noise sounds. So for all my animal lovers over there, it might be something like maybe an elephant, like, or perhaps a, I don't know, I can't come up with any other animal noises that I can make right now. Maybe a monkey could make a monkey noise. I think that would be much cooler. Have a great night, everybody. A what? A goat. A goat? Yeah, I can do a goat. Have a great night, everybody. Bye-bye.